Have you ever stood by the ocean and just thought, wow, this thing is massive? It feels like it's way too big for us to ever really hurt it, right? For a long time, that's kind of what we all thought. But we've hit a point where all the stuff we produce, the sewage, the chemicals, the trash, it's starting to overwhelm our oceans. So today, let's take a look at what's really going on just beneath the waves. Here's the game plan. We'll talk about the ocean's breaking point. Then we'll trace where these toxins are coming from. After that, we'll see how this creates a poisoned food chain, how that connects directly to us, and finally, what we can actually do about it. All right, first up, the ocean actually has its own built-in defense system, but it's starting to fail. Let's dig into why. This really is the big question, isn't it? It just seems so huge, so powerful, you'd think it could absorb anything and everything we throw at it. But as we're finding out, that idea is, well, it's dangerously wrong. You see, water is actually amazing at cleaning itself. You've got bacteria that break down waste, natural processes that neutralize acids, sunlight that helps decompose things. There's even a process called oxidation that zaps some pollutants. But here's the catch. These systems aren't infinite. They have a limit. And when we dump too much waste too fast, they just get completely overwhelmed. They just can't keep up. So where is all this pollution even coming from? Let's play detective and trace these toxins back to their source. Okay, so pollution basically gets into the ocean in two main ways. The first is what we call point source. This stuff is easy to spot. It's coming from one single identifiable place. Think of a big pipe from a factory. But then there's non-point source pollution, and this stuff is way sneakier. It's the runoff from, well, everywhere, which makes it incredibly hard to track down. And here you go. This is the perfect picture of point source pollution. It is direct, it is obvious. You can literally point your finger at the problem. It's waste coming from one single pipe. Now compare that to non-point source. This is more like death by 1,000 cuts. It's the fertilizer from a farm over there, the oil that dripped from a car on a city street, the trash that gets washed down a storm drain. All of it slowly makes its way to the ocean. And because it comes from everywhere, it's kind of everyone's fault, which means it often becomes no one's responsibility. So once all these pollutants are in the water, what happens then? Well, they don't just disappear. Oh no, they start a really dangerous journey up the marine food chain. Let's use pesticides as an example here. These are chemicals literally designed to kill things, and a lot of them are what we call non-biodegradable. That's just a fancy way of saying that nature can't break them down. So once they get in the water, they just stay there, waiting. And this is where things get really bad. It's a process called bioaccumulation. Here's how it works. First, tiny organisms at the very bottom of the food web absorb these toxins. Then, a small fish comes along and eats hundreds of those little guys, concentrating all that poison in its body. Then, a bigger fish eats a bunch of those small fish, and the concentration gets even higher. It's like a toxic ladder, and by the time you get to the top predators, the dose can be deadly. And you know, it's not just the invisible chemicals we have to worry about. The most obvious culprits are plastics. And just like those pesticides, they're non-biodegradable. So every single piece of plastic that finds its way into the ocean can stick around for centuries. It might break down into smaller and smaller pieces, but it never really truly goes away. And the harm that plastics cause is just direct and brutal. A turtle sees a plastic bag floating and thinks it's a jellyfish, its favorite food, so it eats it. That plastic fills up its stomach, and the turtle starves to death. Birds and seals get tangled up in things like plastic six-pack rings and old fishing nets, which can lead to injury, drowning, or strangulation. It's awful. So clearly, this is devastating for marine animals. But why does this matter to us, beyond just caring about the wildlife? Well, because that poisoned food chain doesn't stop with a dolphin or a shark. It ends with us. Look, contaminated water is a direct threat to our health. When sewage isn't treated properly, it can spread diseases like cholera and typhoid fever. And these aren't some far-off problems. These are serious, sometimes fatal illnesses that we can get from drinking or eating from polluted sources. And hey, remember that toxic ladder we talked about, bioaccumulation? Well, guess who's often at the very top of that food chain? We are. When we eat seafood from polluted waters, we're eating all those concentrated chemicals they've absorbed. This includes nasty stuff like PCBs, industrial chemicals that were banned years ago but are still hanging around, and they're known to cause things like liver damage and even cancer. Now, beyond all the invisible chemicals, there are also those big, catastrophic pollution events. An oil spill is one of the most horrifying things you can see. And this quote, it just cuts right to the chase. For a bird, getting coated in oil isn't just a matter of getting dirty. It's a death sentence. It destroys their feathers' natural ability to repel water and keep them warm. Sea otters are another heartbreaking example. See, unlike seals or whales, they don't have a thick layer of blubber to keep them warm. All their insulation comes from their super dense fur. When oil gets in that fur, it mats it down, and they can literally freeze to death. They also get poisoned when they try to lick the toxic oil off their coats. So when we're faced with these huge pollution disasters, what can we even do? This brings us to how we respond, and more importantly, why preventing the problem is always better than trying to clean it up. Let's just look at the Exxon Valdez spill back in 1989. About 11 million gallons of crude oil poured into the crystal clear waters of Alaska. And get this, the numbers you see here for wildlife deaths, those are just the bodies they actually found. The real number is way, way higher. It was an environmental catastrophe. After a spill like that, crews rush in with a few main strategies. They can use these long floating booms to try and contain the oil, they can spray chemicals on it to try and break it up, or, in some situations, they can actually set the oil slick on fire. But honestly, every single one of these methods has major problems. And here's the absolute bottom line. Cleanup is a desperate, last-ditch effort. Whether it works depends on the weather, the waves, how fast people can get there, and more often than not, it's just too little too late. The real damage, the catastrophic damage, has already been done. So, if cleanup is basically a lost cause, what actually works? Prevention. That's it. It's the only real solution. That means building safer ships, like tankers with 2 hulls instead of 1. It means smarter traffic control in busy shipping lanes. And it means having, and actually enforcing, strong regulations to hold polluters accountable. And that leaves us with this final thought. We know that trying to clean up our oceans after a disaster is pretty much impossible. The damage is often permanent. So the real question isn't about how we'll clean up the next big mess, but whether we have the will to do what it takes to stop it from ever happening in the first place.